and water, various salts and proteins, which are all a good electrical conductor. Ohm's law, current equals voltage divided by resistance. This also applies to the human body. Only the skin as an insulating material offers resistance to currents entering the body. The skin resistance decreases with increasing voltage.
If the human body is connected into an external circuit, then the current bursts through the insulating skin and the body's own weak electrical signals become overwhelmed. The muscles contract strongly and the brain's command to let it go cannot be followed. 10 milliamps is enough to hold you to the current.
It is known that current always takes the path of least resistance. On this path lies the heart, which has its own rhythm and can't be influenced by the brain.
If an external current is superimposed on the heart's own rhythm of between 70 and 80 beats per minute, then the heart can no longer pump. The heart goes into an irregular spasm of up to 3,000 beats per minute, so-called fibrillation. The circulation falters. The body's organs are deprived of oxygen, mainly the brain. The heart stops. And without help in the next 5 minutes, that's the way it will stay.
All this can happen, as we've already mentioned, not just when the human body comes into contact with high voltage. It can happen even at low voltage, for example in the range of 50 to 400 volts.
A distribution cabinet, also low voltage. We'd like to show you in a test the effects of an electrical arc without the body being exposed to any direct physical contact to the current. In front of the cabinet we have the perfectly protected workman. Low voltage HRC fuse with forearm protection. Protective helmet with face visor. Cotton shirt. Work overall in accordance with DIN 66083. Minimum of 35% cotton and close fitting. And lower down, a rubber mat and protective shoes. As we said, perfectly equipped from head to toe. How does the arc affect him? We filmed the test with 2 cameras, one running at normal speed and the other at 500 frames per second. The duration of the arc is 1.6 seconds. The same scene in slow motion. Current strength 5,000 to 6,000 amps. Temperature of the arc 8,000 degrees C.
So let's see what's happened to him. Face visor and helmet have protected him well. Head, hair and neck are okay. There are no injuries to his hands. The overall protected the body from burn injuries.
The same test with a colleague, but you don't have to look hard to see that something is wrong here. No protective helmet, no face visor, the shirt is made of synthetics, no protective gloves, but instead, he's holding a pair of pliers and wants to work on the cabinet. And finally, he's standing on solid concrete in normal street shoes. The arc, 6,000 amps, 8,000 degrees C. Slow motion. Enough energy to supply a city suburb, all concentrated in a fraction of a second over a few square centimeters.
Let's see what has happened to him. Anybody of flesh and blood not equipped according to the safety requirements would at best have suffered serious electrical burns. The destroyed cabinet and melted pliers are a proof of the destructive effects of an electrical arc. Yeah, but it couldn't happen to me. I'm an electrician. I know the right way of doing things. Admittedly, it looks as though he really does know his job. But unfortunately, it's not always the case.
A study over a 15-year interval reported 25,000